All right. I guess we are live now. Welcome everyone to this session of the Winner Conference. Let me introduce myself first. My name is David Marpaung. I'm a professor at the University of Twente, the Netherlands, and also with INP in Indonesia. And we are now at the winner session on smart and energy efficient city. So the session right now is co-organized by a few organizations, that is INP Indonesia, IKANET, which is the Ikatan Alumni Netherlands, and Ikatan Alumni ITB. So these are alumni associations in Indonesia. So in this session, we will have 5 excellent speakers, both from Indonesia and also from the Netherlands, covering various topics around green energy for sustainable communities in our cities, which is a very important topic that we are facing right now. The talks will be ranging from state-of-the-art technologies to government and public policies. So let me tell you a bit about how we are going to organize this session. The speakers will have around 8 to 10 minutes talk. So these are short talks from the speakers introducing the topics. And then we will go until all the 5 speakers finish, and then we will have a panel discussion at the end, right? So in this case, you in the audience are very welcome to put your questions in the chat, and then we will sift through those questions, and then I will bring those questions to the panel discussion towards the end. Excellent, excellent. So let's start now with the first speaker. So our first speaker is Dr. Dian Afriani. So Dian is a co-founder of Lokahita and she's a climate leader in Indonesia. She received her PhD from Institute Technology Bandung, and she has more than 20 years professional experiences in disaster risk reduction, climate change, and urban planning. And today she will be updating us about the current state of our climate crisis. Dian, please. I think you're still muted.
Thank you, Professor David Marpaung. Yeah, this is my slide. Thank you. Thank you for the opportunity, and good afternoon, ladies and gentlemen. To begin this session, I would like to share the current update on the climate crisis, as we are dumping pollution every day from our daily activities. Next, please. Okay. Our cumulative pollution has been recorded by scientists since pre-industrial era, and it shows the correlation with the global warming. 2 months ago, the update has been launched by IPCC. It shows that global temperature has increased 1 degree caused by our pollution. It will rise significantly up to 3 degrees if we do nothing. And why 1 degree matter for us? Why it's code red for humanity? The warming planet will have irreversible impact to the Earth system, and as a result, it generates climate catastrophes. The number of climate-related catastrophes have been going up worldwide. In 2019, more than 700 disasters were registered around the world, with overall losses totaling $150 billion. And next, please. Sorry. Yeah, next. Next, please. And warmer temperature have an impact on the spread of tropical disease. This means there are more and more places where a disease like Zika can take root. Next, please. Overall, based on scientific evidence, the impact of global warming has generated all these threats. Thus, global warming is the #1 threat to the global economy. Next, please. We humans have solutions, but climate crisis is a complex issue, and it should be addressed through systemic approach. To address the impact, we need to adapt. And to prevent the causes, there are several mitigation efforts to cut the emission. Both of them to be designed and conducted based on scientific evidence, and it requires everyone to involve, not only the government. Next, please. In 2015, world leaders committed to reduce global emission to halt the warming below 2 degrees. We know it as a Paris Agreement. Climate crisis has different impact to each countries and community. The poorest are the most vulnerable to the crisis. This is why common but differentiated responsibilities are applied to cut the emission, which means rich countries need to support the poorest through financing adaptation and mitigation effort. Based on the Paris Agreement, each countries need to submit their plan of 2030 emission cutting pledge. We call it as NDC. Next, please. To date, only 59% of global emission covered by new NDC submission. Next, please. Even though all countries implement their current NDC target, there is a significant gap to reach the Paris Agreement in 2030. And we only have less than 9 years to fill the gap before the impact is irreversible and cause more crisis and catastrophe. Next, please. The gap is not only the emission, but also the production of global fossil fuel. Global fossil fuel production plan remains dangerously out of sync with the Paris Agreement limit. Next. This is why we need to ask our leader to set more ambitious target in reducing the emission and raising the financial support for the poorest, so we can limit the temperature below 2 degrees and adapt with the current impact. Moreover, the role of non-state actors in achieving the target need to be defined clearly, such as cities, regions, and private sectors. I highlight cities here, as other speaker after me will elaborate how cities can participate to reduce the emission. Next, please. Cities are growth center, where economic and social activities conducted. The cities are the highest emitter, as well as vulnerable to the climate crisis. However, up until now, cities are excluded from NDC schemes. There are no clear linkages between national strategies and cities planning to reduce the emission. Next, please. However, 100 cities worldwide have policies in place regarding renewable energy, but most of them located in North America and Europe. In Asia, Jakarta is one of them. Challenges for cities in emission reduction are vary among locations. One of them are the conflicting policy between national and city level. Next, please. Nevertheless, cities can contribute to cut emission through several approaches, but not limited to green building design, green infrastructure, smart grid technology, and electric vehicle. And those of all will be discussed by my fellow speaker in this session. Next, please. Yeah, that's all from me, Professor David. Thank you.
Okay, excellent. Thank you, Badian, for this very enlightening update about the current status of our climate crisis. So, as I mentioned before, we will go on to the next speakers, and then we will take questions at the end during the panel discussion. So please put your questions in the chat. So our next speaker is Prasetyo Adi. He's a professional architect and urban designer. He is the founding partner and managing director of PDW, an award-winning design firm. He is also one of the core founders of Green Building Council Indonesia and has been involved in the architecture and planning review board of Jakarta. And today he will be speaking to us about smart city towards net zero healthy. Prasetyo?
Thank you, Pak David. Good morning and good afternoon in Indonesia. Yeah, in this occasion, I want to talk firstly about building. Next slide, please. Yeah, that we need to achieve the SDG as soon as possible. We are already behind, and green building. Next click, please. That we are focusing on number 12, although we are involved in at least 9 of these SDGs. We are in the chain of sustainable, responsible consumption and production. Next, please. I'm starting with the building because we believe and data shows that building affect 30% of the whole CO2 emission and more to that to the energy use, especially in the urban area. We can see that healthy building can increase productivity and also avoid inefficiency. And it can be done through by way of system, but also as a passive design. Next, please. There are features that make healthier. This, in example, this one is in office setting that with indoor air quality and ventilation and thermal comfort, daylighting and proper lighting, acoustic, amenities and feel, biophilia, connected to nature, and interior layout and active design can improve the how the office works. Next. And the main concept of digitalization is that devices are integrated with the internet, and by tracking, sensing, and monitoring objects and their environment. Next, please. That the question is how, if we embed it and how we use it to our advantage in green building or green cities context. Next, please. So few of the smart building aspects in our daily in urban settings. First and foremost is energy. How do we meter? Then from meter, we're not only measuring but also response to it. Then lighting. How lighting can be in tropical country like us. It's given. It's like 12 hours a day. So we try to use as much as possible natural lighting. In terms of safety, fire, 24/7 monitoring for building. And then in the future, Indonesia is already starting a few buildings that we have EV charging. How we control water, FEHC, elevators, vertical transportation, access and security. Next, please. And like I mentioned before, the Internet of Things in building, what we use now is for sensors and automations. Next, please. Including the how we use for water control, including watering the garden, the green area, water quality, and spotting the leakage. Next, please. And also for indoor health comfort, how we next slide, please. how we monitor mechanical ventilation and or air quality. Next, please. Yeah. Next slide, please. So, IoT can be integrated in smart building system by working through installed sensors. Some other things can be fixed by itself. So, IT cannot help repair. It cannot replace broken light bulb, for example, but it can give you a data that you need to control and feedback. It gives you feedback that there should be somebody responsible to take on that. Next, please. Owners and building with automation and metering equipment can use data, and it should not be a heavy investment, but it will make the building more efficient and more environmentally friendly. Next, please. And it should be always be able to be extended, because the technology, as we know, and the parameter always change, and we have to be ready for the change, especially through this digital age. Next, please. With enabling data-driven decision making across organization, among the from the beginning, from the when we design the building construction, and then the most importantly when we operate the building, not only building manager but also how we communicated with tenant. But one more important thing is how we make the decision by that by acknowledging the data. Next, please. BIM, as I mentioned earlier, is very useful to start to begin the design when we talking about green building and construction. Building information modeling we use as a tool in this instance. Next, please. And we come into city network. It has to integrate to city network for more accurate integrated efficiency and data comprehension. So it's then from the building manager is to the city manager, like this. That smart city is using information and communication technology to enhance the quality of the city services, as we know. So not only that we need the basic infrastructure of digital infrastructure, but also the people, the knowledgeable people, and good leadership decision maker. Next, please. As we know that 80% of the global CO2 emissions worldwide consumed by city and urban populations only grows, and smart city can improve the efficiency with their services. Next, please. Sample city of Chicago has implemented array of things that give data and feedback to the decision maker. Next, please. And I come forward with these strategies from the project that we work on. First, mobility, how people in the city settings move, including using the Google Maps, Waze, things like that. But most and foremost, how we walk is important, especially in Indonesian context. Environment, climate change. You can see all the points that how we monitor and give feedback. So there should be a central or sub command center. Then urban system, how the cities get feedback from waste, water, and all services. Next, please. There are 6 strategies that I come forward. The public sector, how the public sector can digitize their information. Next, and then livability and vibrancy. And then, of course, security and safety. Next, please. And it has to be connected amongst governments and citizens alike. Next. And as we all know that there's not just a building, but also you have to start with your mindset. Next. With a healthy building, we got the healthy people that will work this out. So how technology, knowledge come together next, and we could only do what as far as you can measure and manage it. Thank you very much.
Thank you, Mas Tio, for the exciting update about green buildings and then how we can implement it. We will move to the third talk now, and then the third speaker will be Dr. Barman Tambunan. He is the Director of National Laboratory for Energy Conversion Technology at BPPT in Indonesia. Has more than 10 years experience in the design and development of various modern power plants. He is also part of the ICANET Presidium, which is co-organizing this session, and ICANET is a platform for alumni from the Netherlands residing in Indonesia. So Pak Barman, please.
Okay, sorry, it was still unmute. Yeah, okay, it's clear now. Okay, thank you very much for the opportunity that has been given to me as speaker in this winner event for Mr. David Marpaung and also all the speakers. First of all, let me introduce myself. My name is Barman Tamunan from the National Research and Innovation Agency, the Center for Energy Conversion Technology, which is located in Puspitek area, Serpong, Indonesia. We also have a research group called INPES, which is my team, which is conducting the research related to what I will convey this event. INPES is Intelligent Power and Energy System. Okay, allow me to deliver my presentation. Next, please. Yes, I will start with the 5 pillars of the third industrial revolution, which is this is I think is important. So since we are shifting to renewable energy at the moment, transforming the building stock of every continent into micro power plants, to collect the renewable energies on site, deploying hydrogen and other storage technology. This is very important in every building and throughout the infrastructure to store intermittent energies, using internet technology to transform the power grid of every continent, and transitioning the transport fleet to electric plug-in and fuel cell vehicles that can buy and sell electricity on a smart continental interactive power grid. So this is the 5 pillars of the third industrial revolution. Next, please. So globally, the energy transition is driven by what's so-called the D drivers, the D4 drivers, the decentralization, digitalization, decarbonation, demand disruption. Decentralization means the mechanism to move away from big centralized generation. Decarbonation means the mechanism is bring to the transition to a low carbon future. Digitalization means the mechanism to more automated operation of the system, and demand disruption means the mechanism in utilizing customer as active elements of the system. Next, please. So globally, the energy is also enabled by what they call the three enablers. So it's the renewable energy source, the power grid and infrastructure, and also the energy use and efficiency, which I will come deep into these topics. Yeah. So in the big pictures, yeah, as we can see, how do you change this energy landscape, yeah, with so many losses from the generation side to consumer energy side, yeah. Next, please. Next, please. Yeah, thank you. As we've seen that the Indonesian demography is increasing in time, and it might also in turn increasing the energy demands naturally, while the dominant energy generation are core power generators. Yeah. Next, please. Next, please. Yeah. So we see that in the energy supply, it's increased. Also, in the demand side, it's also increased. But seen that because of the losses, yeah, we have also seen in the this red side here. That means that we have losses of energy, yeah, from the general side to consumption. Next, please. Next, please. Yeah. So several of the mitigation mechanism may be there from generation side until the customer side, yeah, with the constraint as well as follow. So the idea of the research is going to be processed like this. Next, please. As evident, technically feasible and economically viable for carbon emission reduction in the lowest customer and user side based on technology clearinghouse as part of energy task through model of assessment, power system analysis, and techno-economic assessment in creating a full front-end engineering design until detailed engineering design and validation process in creating bottleneck solution that ready to implement or deliver. With in the consumption and end user side, we see like more utilization of renewable energy, efficient on demand, aggregation of users, yeah, and enhancement with HIS and new business model. Next, please. Yeah, next, please. So self-sufficient, sharing the excess of renewable energy source and aggregated by communal. This is something that we will offer in this discussion. Next, please. Yeah. So this is something I think important to be discussed. First of all, is that as we've seen from this picture that the next, please. Yeah, the installed generation in Jawa Island, Jawa, Madura, and Bali, which is the largest, biggest electricity backbone in Indonesia, is roughly about 40.11 gigawatt, yeah, with the availability of much as 37.3 gigawatt. Next, please. Where the peak load is only about 26.737, and the highest one happened in December 2019 with 27.933 gigawatt. Next, please. This means that the reserve margin is about 31%. This reserve margin is sufficient but obligated around 30% of large area. But again, the generation side is still dominated by coal powered, which means contradicted with the net zero emission 2050. Next, please. Yes, next, please. So the network infrastructure, while fossil generation is still produce more carbon emission to meet the increasing demand due to demography, pollution, and other related. Whether like or not, the network infrastructure needs to be reinforced, upgraded. Rise of electric vehicle, electric stove substation from cooker gas, and so on and so on. And more investment needed and still populated. Next, please. Yeah, so the sentence is rise of electric vehicle and etc. Next, please. So more investment and infrastructure to meet the increasing in demand. Next, please. Next, please. Yeah, so it is environmental friendly. It is still polluted. This is the question. No approach is using renewable energy and storage, etc. Next, please. Yeah, so this can help. This not only based on the conceptual framework, but also ready to be delivered by existing actors. More, this scheme is also initiating new actors, new business model, and helping the utility of assisting to their services. Next, please. Yeah, so next, please. Yeah, so this is the initiating an evidence technically basically on economically viable via technology clearing for electric-based battery ecosystem to reduce the carbon footprint. Next, please. Yeah, next, please. Sorry, I think I'm running out of time, but I will try to explain this in more in short. So next, please. Next, please. Next, please. Sorry, yeah, this is many infrastructure. Yeah, next, please. Next, 3 times. Next, next, and next. Next, again, next. Yeah, so the existing infrastructure as are designed in old-fashioned construction top-down. Operation do easy operation and maintenance, cheap operation and maintenance, and protecting design, so forth. So let's say all the demand of the customers use lowest area are market with W. So we've seen the green area there are accumulated aggregately, where the new network losses is always linear with the total load demand. Yeah. And as the area are constructed with the several levels, yeah, you've seen in the W, Y area, yeah, A2 area, so forth will be upstream feeder with assigned with M, and thus more waste energy will occur during the process. These schemes are monetized as what so-called biaya pokok produksi or electricity cost production. Yeah, this PP is either burned directly to the customer or government subsidy scheme. Hence, the need of breakout scanners are required immediately because the content of net zero emission commit the schemes are far away than expected. Yeah, next, please. Yeah, next, please. I think I have to go further. Next, please. Yeah, next, please. Yeah, next. Yeah, okay. So I will come to the research scheme. I think better. Yeah. So we will offer a few research scheme from data exploration, and then from clustering of data, data structure, classification data, and then model integration. Yeah, and running the QDMS, which is the quasi dynamic modeling simulation. Yeah. Grid perspective constraint, energy balance scenario, and then from then on we can have some data about objective function towards the new net zero emission of 2050. Next, please. Yeah, next, please. This is an example of the picture. Next, please. Yeah, so the early pass of findings. The early funding has been done by our team with specific residential area to be adopted as much as 200 residents. All data are artificially taken from secondary resources. The installation data of which essential to predict the produced energy from photovoltaic rooftop generation are taken from PVGIS, and all data like from the four-wheel, two-wheel EV data, charging profile are data from automakers that potential market Indonesia. Next, please. Next, please. Yeah, the proposed scheme can reduce the dependency of existing single provider up to 37%, supply energy within 40% participation of end user equipped with photovoltaic rooftop, and the IAS. And the same capacity with their contract service, The scheme only considered to the end user RRD without two-wheel drive, four-wheel drive, EV, and NDC stove. The reduced energy can be achieved up to 22% to the supplied energy, including the RRD, EV, and ES, with 50% participation of end users. Hence, minor improvements such as cable enlargement at point of connection from the end user is necessary to maintain the network regulation. Otherwise, 12.42% of energy dependency can be reached without cable replacement. Next, please. Next, please. Yeah, so one step before. Yeah, so the finding has been done by our team with specific residential area to be adopted here. So the energy losses is reduced up to 11.74% compared to the total energy losses. But in the base case, it is necessary to have an ancillary service provider in a saving 100% fully independent from the main provider, as well as to maintain the stability issues, which is not the case in our early phase finding. And it is needed to run the KDMS for a long duration of 1 year to monetize the reduced energy and energy losses with the measured value of the monetary system or carbon reduction. Our early findings were carried out for a 1-day operation only with a step size of 1,440 minutes. Next, please. Okay. Okay. Thank you very much for a little bit long for my presentation, more than 20 minutes, but I think that's all of my presentation. Thank you very much. Yeah.
No worries. Thank you for the update, Pak Barman. We should move on to the fourth speaker. Now we move to the Netherlands. Speaker from the Netherlands. The next speaker is Dr. Rebecca Seif. Rebecca is an associate professor at the University of Twente, working on light management for bifacial solar cells and photovoltaic devices. And she is also a co-founder of a startup, ETC Solar, and served as the CTO until 2020. Becca, please.
Okay, so can you hear me?
Loud and clear.
Okay, great. Thank you very much, David, for the introduction. And I hope you can also see my screen now. Is that correct? Okay. Can you see it now? Perfect. Good. Okay, yeah, again, thank you for the introduction and welcome to my talk. I saw the title of my talk is Photovoltaics in the Netherlands, so that's actually what I'm going to talk to you about today. So the reason why I'm so interested in photovoltaics is because I think light is an amazing fuel. You don't need any tanks, you don't need pipelines, you don't need wires. And on top of that, sunlight is the most abundant source of energy that we have on Earth. To do a little bit of math here, solar power, or the percentage of solar power that we would need in order to fulfill our energy needs, is very, very small. Like globally, we would only have to convert 0.003% of the total incident solar energy into electricity in order to fulfill all our electricity needs. And this even works out in the Netherlands, which is not a very sunny country. Namely, here in the Netherlands, we would only need 0.26% for the electricity and 2% of the overall sunlight for all energy that we use here in the Netherlands. So really, by capturing sunlight, we can solve the energy crisis. But on top of that, logically, because sunlight is so abundant, this also means that solar energy is now actually becoming the cheapest source of electricity in most areas of the world. So I recently saw this meme, which I think describes it perfectly. If God wanted us to have unlimited free energy, he would have put a giant fusion reactor in the sky, and he obviously did, namely the sun. And we think we should really use this. So luckily, now solar energy is actually getting cheaper and cheaper. In recent years, we've been seeing a lot of articles popping out that show that it is now cheaper to build new solar plant than it is to operate existing coal power plants. And we have seen both in Germany, this is an example from Germany, and this is an example from the US, that now solar energy is being built without subsidies. In the Netherlands, it's actually also getting there. And I know that also in Indonesia, a lot of solar is starting to be employed. And that's also part of the reason, that it's cheaper, is that I actually also put solar panels on my own house here in Enschede in the Netherlands last year, even with some snow. And I did this, of course, on one hand because I'm a solar energy enthusiast, but on the other hand also because it is now a way that you as an individual person can save money. So you pay upfront for the solar panels, and the payback time here in the Netherlands is around 6 years. The reason why this is possible is because the prices have been falling exponentially over the last years. And so we can here see how the prices have been developing as of from 2006, and you can see that the module prices, so the prices of the modules that you can, for example, see here on the rooftops, have really been declining exponentially, and the balance of system, BOS, has also declined, but a little less. So in order to make solar panels more efficient, more like cheaper, what we have to do is to make the modules more efficient and to innovate more. And through research innovations that my colleagues perform, it is possible to make solar panels cheaper and cheaper every year. And not only is innovations making solar panels cheaper, it also makes solar panels more versatile. And this is actually something where the Netherlands is also very much on the forefront. So we have, for example, this Soliance Research Center, where they make these flexible perovskite solar cells. We have Hyatt Solar is a Dutch company that also makes flexible solar cells. And then Heliatech, a company out of Germany that makes flexible and colorful solar panels, and that obviously then creates significantly more opportunities to integrate solar also, for example, with buildings. So I already showed you the very vanilla, boring example of the panels that I have on my own rooftop. But university, for example, EPFL in Switzerland, they have really used it to implement it as a colorful facade. And then Heliatech here out of Germany has these flexible solar cells on these, for stadiums, for example. Hyatt Solar, they really integrate it into different types of roofs. And then others can integrate it also here in these like semi-transparent sunshades and roofs. And then also two very nice examples, particular out of the Netherlands, is this product here by Solar Visuals, where you can barely tell that it's a solar cell, and it almost looks like the standard brick that we're using here on houses in the Netherlands. And then there's also this very nice example here where solar panels were integrated in a street or here in a bike path, done by Solar Road. It's also a startup out of the Netherlands. And so you can see that solar panels can now really be integrated with a lot of different infrastructure possibilities. And if you can put solar panels on a road, then of course you can also think of putting solar panels on a car. And here again, we have like two nice examples out of Europe. So one, Sono Motors out of Germany, then Lightyear, very nice solar car out of the Netherlands. And with a lot of local pride, I'm not involved in this, but still I'm very proud of our solar team Twente, who it's a student group, and they managed to make, design, and fabricate the fastest solar car that's currently on Earth, basically. And so that's actually something that's coming here out of this university. Furthermore, it is extremely important in densely populated countries such as the Netherlands to integrate solar not only with infrastructure, but actually also with agriculture. And so there are now several approaches where we can put solar panels, for example, in a vertical way, and the solar panels, they receive light from front and rear, so-called bifacial solar panels, and then they can just stand on a field, and it's still very easy to perform agriculture and run your tractors through this. And it can even happen that you can get an optimum between solar power and crop yield, because some crops actually like it better if they're not in the full sun, for example, berries. So there's a lot of research going on right now how to optimally yield, or how to optimally get most of out of a certain area, both in terms of energy as well as in terms of agriculture. And I think these are very important and exciting developments. One example from my research group is that we are using nanophotonic surfaces that beam light towards existing solar panels. So we are designing surfaces that we can, for example, integrate with facades or streets that are not solar panels themselves, but that collect all the light and then beam it towards the existing solar panels. And what I would like to mention is that in the Netherlands, but also at the University of Twente, there is a lot going on with respect to solar research. Putting here a picture of my own group and the group of Professor Monica Morales. And these are exciting times for solar research, and there's a lot going on in the Netherlands. And I also know in Indonesia, there's now a lot of interesting progress being made. Thank you for your attention.
Excellent. So thank you, Rebecca, for the excellent presentation about the technological advancement of PV technologies. And we will move to the final speaker of this session. So our final speaker is Dr. Jaco Quist. Jaco is an assistant professor in the Sustainable Innovation and Transitions at the Energy and Industry section of the Technology, Policy and Management faculty at Delft University. His research and teaching evolves around sustainable innovation and transitions, in particular around vision, participatory backcasting, and transition management. So I have to mention that Jaco right now is in this session taking over from Professor Cornelis Blok, his colleague, who couldn't be here today. And then Jaco will talk about energy policy in the Netherlands and Indonesia, I guess. Jaco, please. You're still muted.
Right, sorry that I was still muted. Thank you very much for your kind introduction. And I'm really glad to be here at the Winter Conference and really glad about the opportunity to speak a bit here about energy policy in the Netherlands and Indonesia. And indeed, I'm doing that also on behalf of my colleague, Professor Cornelis Blok, who couldn't make it because he was working on something for the IPCC. But I'm really glad to talk on this also on his behalf, and indeed I'm an assistant professor on sustainable innovation transitions, and within that with a focus on sustainable futures and transitions. Right, but I apply that amongst others to the energy transition, and I would like to say a few things about that, also drawing some comparisons or making some comparisons or between the Netherlands and Indonesia. And of course, what we do know about both our countries is that we have rely too much still on fossil fuels. And in fact, say the Netherlands is still not so strong in its renewable energy, unfortunately. And what you can see on this graph is that the share in Indonesia is even bigger of renewables is bigger in Indonesia than it is in the Netherlands, unfortunately. So there's for both our countries still a lot to do. You can see something similar in the Netherlands. Say the solar and wind is not so big yet, but that's going to be the main sources for the future. But you can see on this graph. Just moving on, and why I'm telling that is because, say, cities as, say, key centers of urbanization, population growth, and say, consumption also need a lot of energy, and that's why it's so important not only to look on the renewable energy integration at the city level, but also on the supply side. I was asked to say a bit about key developments of renewable energy in the Netherlands too. And what I can say is that a lot of efforts are being made, though still more have to be added to meet up or to live up to the expectation of the Paris Agreement in 2015. And that has, amongst others in the Netherlands, led to the Climate Agreement in 2019, delivering an action plan to make that happen. But still much has to be done. So,
yeah,
but I also could...
Sorry to interrupt. We don't see your slides, and then it's not on slideshow, so it's not going. So maybe we can put it on a slideshow and then.
Yeah, that would be better. I'm sorry, I could not see that. I can only see that it is showing.
Yeah.
Then I'll stop sharing and I'll give that back to you.
No, this is okay. And then now you can, if you can flick your slides, for example.
Can you see it now?
It's still on title slide.
I have it now on slideshow.
Okay, so I guess what we are seeing now is the slides being beamed by the organizer, if I'm not mistaken. Can somebody flick the slides? Yeah. So did you see it, Jaco? Now it's.
I have to get back then. If we go to this option, that's fine for me too. But then I will. Yes, the next slide, please. Next slide. Great. I was about here. I'll take it up here. So I was talking about a few key developments on renewable energy in the Netherlands, and I talked about the climate agreement just recently. And I wanted to add that for most renewables, you used to have a feed-in premium system, which is called SDE++. That was already around for a long time. That's a strong driver of growing market share, market presence of renewables in the Netherlands. Though this instrument is semi-competitive, in the sense is that it gives priority to the cheaper or the most cheapest options. It's now in say revision that's not only meant for renewable energy, but it is meant that it will also be developed for other reducing carbon options like CCS. What also would be interesting to mention about a recent development in the Netherlands is that we have these auctions for offshore wind energy for the parks in the North Sea. And now I can say that say these auctions or the developments are that successful that the most recent auctions didn't resulted in bids for the offshore wind parks that are subsidy free. So no further government subsidies are needed for the forthcoming offshore wind parks. Though we should mention here is that the grid connection is provided by the transmission operator in the Netherlands. And that's, that's of course still quite an investment that's not included in that. So what I also would say is that this offshore wind will of course come on shore, and it will take place at 3 different places in the Netherlands. And there they really have to work on the infrastructure, but also on conversion to hydrogen to facilitate that and on the future larger scale. So I also would like to add that there is still a little bit of net metering for domestic solar PV in the Netherlands, but this will be gradually phased out in the coming years. But at the same time, there are new instruments being developed to facilitate, say, PV adoption among citizens and citizens cooperatives. What we can also say about the Netherlands, there is an increased role for the municipalities in the regions in renewable energy planning. And here's quite a nice similarity with the regional energy planning in Indonesia. And in the Netherlands, say, cities and regions have to develop energy visions and regional energy strategies. Say, in the urban sense, there's a lot of attention for phasing out gas for domestic heating, and the increase of solar parks and say energy conservation targets. Well, we also see a lot going on the topic of EV in policy making in the Netherlands. Next slide, please. So just pointing to a few similarities or say connections between Indonesia and the Netherlands. So both our countries have increasing targets for the energy transition. There are also, we see, well, both our countries focus largely on the same sources. Of course, hydro is a bit difficult in the Netherlands. So we see for the domestic heating, we see also a lot of attention for heat pumps. You can also make this kind of comparison for the electricity market. So in the Netherlands, it's more with diversified suppliers and several companies providing the electricity. And say there is also a lot going on the consumer side. Next slide, please. And that is then the shift or the move to talk a little bit more about citizen participation, here more of a focus on the Netherlands. And we see a gradual shift to a more decentralized approach to the energy transition and say activating and engaging citizens and citizen cooperatives. And say, whereas the local governments and the regional governments are making renewable energy plans, it's very strongly stimulated that local actors and citizens participate in the decision-making and planning process. So there should be active participation of citizens to broaden the spaces of public participation in these energy planning processes. There are still considerable difference between regions. There is still, getting started, experiments going on. So not everywhere the participation is as developed, but we are making progress. That then paves the way for more local cooperatives for renewable energy. Next slide, please. And this just gives an impression of how it is developing across the Netherlands. Next slide, please. I would like to say a few things about emerging research topics. And that is that, say, when we see the planning for the energy transition on the long term, we will need a lot of additional materials, some of them critical materials. And some of my colleagues are now arguing that if we want to live up for the energy transition and the material needs for that in the Netherlands and globally, we may have to give the energy transition priority over the electronics industry. Just to make sure that we will live up with the climate targets that we would like to achieve. And that's really an emerging academic issue that's also currently being taken up or noticed by the policymakers in the Netherlands. Next slide, please. Other topics that are getting increasingly important are the use of hydrogen as an energy carrier and the development, the emergence of hydrogen clusters in the Netherlands. The issues with critical materials, I just already referred to that, but we also see an increasing attention for energy justice. So do we share the burden and the costs of the energy transition in an equal and just way among all citizens in the Netherlands? Also important to continue on system integration. And when it comes to the urban energy, there in the Netherlands is a lot of attention for the sustainable heating, insulation, and phasing out the gas. And of course, there is the growth in the EV. Next slide, please. I'm here because I'm involved in a large collaborative project with ITB, and for which are Dr. Hakunti Rahayu and Professor Cornelis Blok are the principal investigators. And I'm just pointing to this project in this presentation because it has this focus on the energy transition and say this is a nice example of research and innovation collaboration between my university and ITB. Next slide, please. This project has a scope on can the biomass from Kalimantan used for the renewable energy supply on the island of Bali. That's the part that's being conducted at this moment by ITB. And we, as TU Delft, have added energy potentials and energy transition at a larger scale. Next slide, please. And I just would like to say that the most recent result we have from that is that we made a review of the renewable energy potentials in the Netherlands. It's just been accepted for the Journal of Energies. And there you can see that the potentials, that there is not only the regular potentials that are regularly talked about, wind and solar and biomass, but that Indonesia has also a huge of not yet exploited ocean energy potential. Next slide, please. Some other points that we found in the study was that most of the potentials are still from the ministry. There's not so much academic work on national renewable energy potential, so that we researchers still have to do in collaboration. And the energy potentials from the academic literature are on average higher one than from the ministry. So we also found out that the potentials that we are more than enough to supply the future electricity need of Indonesia. Next slide, please. That's what I'm showing here. I think I don't have time, so I would like to move on. Next slide, please. This slide refers to the work by students. A part of them are in our course programs, part of them are Indonesia. And I just would like to mention here is that, it's not only about research collaboration, but also about educational collaboration for innovation at this conference. And we involve our students in our research, and they make meaningful inputs on several relevant topics for the energy transition research on Indonesia and our collaboration. Next slide, please. So cities have a higher energy and electricity demand. We see considerable progress in energy policy both in the Netherlands and Indonesia, but we have to work on adjustments and updates in our research agenda too, which give interesting opportunities for collaboration, where students are also important as we researchers are. Next slide, please. Here I would like to leave it for today. Thank you very much, and looking forward to your questions and the discussion and any other presentations if there are still to come.
I think we've gone through all the presentations, so I would like Angel to, the organizer, to bring up all the speakers, and then we will move on to the panel discussion. Excellent. And we are missing Dian, I think. One more presenter. I will assume that she will come. Okay, so excellent. So we have talked about a wide range of aspects, from really the climate aspects down to the cities, down to the technology and management and policy, right? So this is quite a lot to take in. I got some questions, let's say, and then I would start with the very first one in the global aspect, right? So I think most of us are familiar with the recent IPCC report about the role of cities in the net zero emission target, right? And it seems that we can play a lot role in terms of cities. So I would like to have two contrasting aspects, maybe from the Indonesian aspects and from the Netherlands aspect. So I would like to ask Mbak Dian to give the input about what is the biggest obstacle to implement this big role of cities into net zero emissions in Indonesia. And I would like Jaco to follow up to give the perspectives from the Netherlands. Mbak Dian?
Okay, thank you, David. I think it's not only for Indonesia, it's worldwide that NDC scheme to reduce the emission based on the Paris Agreement has not clear linkages between state or national strategy into cities planning. However, there is several, like 700 cities worldwide that already implement their planning and strategies to put renewable energy into several sectors. In example, for the power system and also transportation system. So in Jakarta, there is, as we know, that Transjakarta buses has already used electric vehicle, and there is also residential that use solar home system. But it's not on the structural or systemic planning into city planning or urban planning. Yeah. And the challenge here in Indonesia, especially, there is some a conflicting policy between national and also city level. On the national level, there is still subsidized on coal for energy, for fuel for the fuel, for the energy. So how can city beat this subsidy to implement the clean energy at the city level? There is also lack of data to implement or to formulate the renewable energy or green energy in city. I think that's what's happened in Indonesia.
Yeah, I think that is a really nice point that Mbak Dian brought up. And then I would like to segue to Yako, because then this is related to policy, and I think you have overview between the policies in Indonesia and the Netherlands. Can you comment on that? You're still muted.
Yes, what I would like to add here is first, of course, we aren't living up to the Paris Agreement, yet, and we're going. So we know by now that it's too little, and that we're going too slow. So what we see around the world is that we're just getting more awareness on the climate change issues due to natural disasters. So there is a huge additional effort is needed. When it then comes to cities, is that actually the policies are just starting to develop. They're not yet being implemented because we have this policy cycle, of course. What is interesting in the Netherlands, I think, is that cities and municipalities were more ambitious for quite some time than the national government and say the national obligations. And they've been working for a while on, say, climate neutral visions, renewable energy visions for the cities. Now they're also working on circularity visions. What is always the issue with visions? Everyone can make that, but do you live up to that? What do you do with that? And what we do see now in the Netherlands with those visions of the front-running cities is that they really use that for local policy making. Making, plans at the district level and putting living labs into practice to start experimenting, because you need a lot of mass and you need a lot of changes, and you have to start small to be able to scale it up on the long term and put it in a pathway. And there we see really interesting things happening. And we have these obligations for regional energy strategies that are more recently. But we still see it's quite complicated to get meaningful participation and engagement, and not to go for the too easy solutions, just put a few solar parks, but really get the better and the more just solutions and strategies. And there's still a lot to gain because it's really a complicated matter.
Excellent. Thank you, Yako. So this is also a nice way to segue into Mas Tio. There is a question from the audience about the role of local government in the implementation of this smart city in Indonesia. Can you comment a bit on that?
Yes, David. Of course, the local government will play a very important role. The thing is that we need to increase their capacity, as now there are a lot of information that they have, but without leadership and decision making. Jakarta has started the slides, the two smart city strategies that I showed you. It's what we present to government for the new capital city. So it's a totally blank greenfield development. But how about the existing cities? So there should be a capacity building and understanding of the smart city and the need for the also smart governance, of course, with the local government, how they respond to the data that they have. Just last month we met with a governor from the east of Indonesian, one of the East Indonesian province, that he understands very well about the abundance of solar energy, for example, and he makes use a lot of it. But that's just one aspect. But we need to integrate all aspects. And now we are developing new port with renewable energies, new resort development that will also host G20 meetings next year with this. So I hope this showcase can be amplified, like Yako has already mentioned, that we can start small. There's already example for example rooftop solar panel, but we need to to expedite the capacity building of the local government and citizens alike.
Excellent. Thank you, Mastio. Okay, I would like now to discuss a bit more about technology and management of energy, and then I would like to discuss with Pak Barman and Rebecca. So we heard a lot about PV technologies as the future of energy, and then Pak Barman in his talk was talking about new ways to regulate and then to regulate these systems, right? So I have a question from the audience asking about these new ideas for regulation. Has it also been implemented for PV energies, and then how would that play a role in Indonesia? And then later on, I would like Rebecca to give the perspective from the Netherlands. Pak Barman, is that clear?
Yeah, okay, thank you. Sorry.
Yeah, excellent.
Yeah, okay. So thank you for the question, Mr. David Marpaung. Yeah. So the question is whether this is I have read here about the applicable to all residents area in Indonesia. I think that's one of the questions from the audience. Yeah.
Yeah.
Okay. Yes. Currently, actually, we are in the process of collaborating with PLN, and of course, as a National Research and Innovation Agency, or BRIN, this will be an important discussion for both parties. And the idea is, of course, 100% applicable, in Indonesia. If the operators like PLN will a little bit change, and also to support, in this case, we also have to follow the regulation issued by the operator, which is in the case is PLN. Frankly, we really want to know how the response from PLN, as the only company that provides electricity in Indonesia, to respond this issue, gitu. And this idea is to initiate bottom-up scheme to reduce the dependability from coal power generation, which contributes huge carbon footprint. Maybe that, Mr. David.
Yeah. And Becca, I mean, like you have experience also about you install solar panels in your home, right? So maybe it's also a good perspective in this context to give an idea about how that is regulated in a real application, right? Because then you install the solar panel, you generate it, and then you give it back to the network, and then etc. Can you give an idea about that, how it's implemented in the Netherlands?
Well, I can give you an idea from the perspective of the homeowner. I think from a bigger perspective, probably Yako is the expert here on the panel. From the perspective of a homeowner, it's actually quite easy right now. Like you get these solar panels, there are no restrictions. You're allowed to put this on your roof. You just have to tell the grid company that you did it, and then you are using your own electricity. And there's this like net calculation basis where you whatever you produce, what you use yourself, you basically don't have to pay for. And then at the end of the year, they do the calculation: how much did you produce, how much do you use? And then only for what you used more, you have to pay, or for what you produced more, you get some money basically paid back. And at the moment, it's for like household or for house owners. It's very simple in the Netherlands to do this, and it's also subsidized in that way. And this is certainly not the way to the future, which also Yako explained. But maybe he can comment on what he wishes should be the way in the future.
Yes, let me add a little here, if possible. Yes,
Yeah.
I know. Say that for the house owners, it's quite doable, feasible. But I would say that for say cooperatives, it's growing, but it's still a lot of work and quite complicated. And when you have like a roof on a school or a company that has a single roof owner, it's still doable. But I'm actually with my I'm living in an apartment building or a block of houses, and say the roof is partly of the owners and partly of the say the association of house owners, and that's getting really complicated, and there are still a lot of legal and financial and loan hurdles to make that happen. Actually, we're putting that currently in a proposal for the Research Council what needs to be done there too, to really get the cooperative movement and the energy citizenship going further.
Okay. I'm watching the time now, and I think we will wrap up very soon. But then, is there anything that the panel wants to address and comment before we close? I think this is a starting point. So the vision for from the organizer is really fostering discussions from this many level of discussion between the Netherlands and Indonesia as well, and then hopefully from this session we can have take-home points that can be implemented for both policies and activities both in the Netherlands and Indonesia. So before I end, I have to mention that this is a starting point, and we are following up with more activities on sustainable development goals and then understanding what has to be done. And the next one will be a workshop that we will arrange on November 20th in collaboration also with the Institute of Technology Bandung. So I would like to thank all the speakers for this vibrant discussion and very clear and nice presentations. And then on behalf of the organizers, I would like to thank you all. Bye-bye.
Bye.